All right, guys, good morning or good afternoon, depending on what time of day I have you. Today we are going to discuss and learn trend lines. It's very simple. What we're going to take is what we did on Tuesday of last week, which is scatter plots, where you have a table, you plot the plots. Okay, so this only works with scatter plots that have linear association. Okay, so when we discussed scatter plots last Tuesday, we did discuss how some have a positive association and negative association. That doesn't really, but if it's linear, if it kind of makes a line, then that is a linear association. If there's no association, if it's crazy and erratic, we can't use trend lines for this. But let's talk about this real quick before I show you an example. Okay, so a trend line is a straight line that comes closest to the points of data values on a scatter plot. So basically you have all the dots going, kind of crazy, and then you have a line that goes straight through it with dots on either side. Super close, pretty much hugging the trend line, okay? I hope that makes sense. All right, so now when there is a linear association, we can use the line to show the relationship of the data between the X and the Y variables, okay? Which is basically what we were just talking about. All right, now, we can use a trend line to make a prediction from our scatter plots. So what we can do is we can take that trend line, and then if they asked us a question that was like, you could use the trend line and you could look at your x-axis and your y-axis, and it may say, like, I don't know, if you're talking about like a farmer who pounds of pumpkins. So you can look at that trend line. You can say, okay, 20 pounds of pumpkins. I don't know, but I mean, there's so many. I'm not saying I don't know. I do know. There's so many different examples out there. Okay, so you can use that trend line and we can predict about what's going to happen. Okay, it won't be precise, but anyway. Okay, so then we can write an equation for the line to make the predictions. So then we can take that, we can write an equation because we already know how to do y equals mx plus b, slope intercept form. We know how to do that. We know that m represents slope and the b represents where it crosses the y-axis. And then what we can do to make our predictions is we can plug in numbers for x and y, okay, or for x and solve for y, or we can plug in something for y and solve for x. Okay, so this is not very hard. I'm probably going to have to screen record like probably a YouTube video to show you some examples because I don't have a grid on here, okay? So I promise today is easy, okay?
This math test included a survey question asking how many hours students had spent studying for the test. The graph below shows the relationship between how many hours students spent studying and their score on the test. Shira drew the line below to show the trend in the data. Assuming the line is correct, what does the line slope of 15 mean? So let's see. The horizontal axis is time studying in hours. Vertical axis is scores on the test.
Okay, real quick. You guys are going to have to make sure that you're paying attention to your x-axis and your y-axis because that's when we write an equation for that line, we can plug in numbers for either the y-axis or the x-axis and solve for the opposite, okay?
Each of these blue dots represent the time and the score for a given student. So this student right over here spent, I don't know, it looks like they spent about 0.6 hours studying and they didn't do too well on the exam. They look like they got below a 45, looks like a 43 or 44 on the exam. This student over here spent almost 4.5 hours studying and got, looks like a 94, close to a 95 on the exam. And what Shira did is try to draw a line that tries to fit this data. It seems like it does a pretty good job of at least showing the trend in the data. Now, slope of 15 means that if I'm on the line, so let's say I'm here, and if I increase in the horizontal direction by 1, so there I increase by the horizontal direction by 1, I should be increasing in the vertical direction by 15. And you see that. We increase by 1 hour here, we increase by 15% on the test. Now, what that means is that the trend it shows is that in general, along this trend, if someone studies an extra hour, then if we're going with that trend, then hey, it seems reasonable that they might expect to see a 15% gain on their test.
Yes, makes
Now
sense.
let's see which of these are consistent. In general, students who didn't study at all got scores of about 15 on the test.
Okay, guys, now you know that happens in real life. Y'all, if y'all don't study, y'all are making about 15s in my class on the test.
Well, let's see. This is neither true. We don't see that these are the people who didn't study at all and they didn't get 15 on the test, and that's definitely not what this 15 implies. This doesn't say what the people who didn't study at all get. So
but that is what happens.
That one is not true. Let's try this one. If one student studied for 1 hour more than another student, the student who studied more got exactly 15 more points on the test. Well, this is getting closer to the spirit of what the slope means, but this word exactly is what, at least in my mind,
yeah, that word exactly, a little scary.
Messes this choice up. Because this isn't saying that it's guaranteed that if you study an hour extra that you'll get 15% more on the test. This is just saying that this is the general trend that this line is seeing. So it's not guaranteed. For example, we could find this student here who studied exactly 2 hours. And if we look at the students who studied for 3 hours, well, there's no one exactly at 3 hours, but some of them, so this was, let's see, the student who was at 2 hours, you go to 3 hours, there's no one exactly there, but there's going to be students who got better than what would be expected and students who might get a little bit worse. Notice there's points above the trend line and there's points below the trend line. So this exactly, you can't say it's guaranteed. An hour more turns into 15%. Let's try this choice. In general, studying for 1 extra hour was associated with a 15-point improvement in test score. That feels about right. In general, studying for 15 extra hours was associated with a 1-point improvement in test score. Well, no, that would get the slope the other way around. So that's definitely not the case. Let's check our answer. We got it right.